See, we are going to discussing about the concept of indefinite integrals. In indefinite integrals, already we discussed about the derivative and its inverse process. See, the process of differentiation and integration are inverses of each other in the sense that d by dx of integral f of x dx is the integration of f of x dx is capital Fx plus c, and the derivative of capital Fx is nothing but f dash x, and the constant derivative is 0. So f dash x is nothing but it is the antiderivative part, which is we call as f of x. Similarly, look at this second one. Integral of d by dx of f of x dx is equal to d by dx of f of x means f dash x dx. So f dash x dx integration is nothing but fx plus c. So where c is an arbitrary real constant or real number, we can say. See, basing upon this, we can take some examples. Example, derivative of x cube, what we say generally, 3x square, and integral of 3x square dx is equal to, you get 3x cube by 3 plus c, which is nothing but x cube plus c. See, the derivative of x cube is 3x square and the integration of 3x square is x cube plus c, where c is an arbitrary constant. On the same line, you can take the derivative of x square plus c, suppose, or you take x cube only. What is the derivative of x cube? 3x square. The derivative of constant is 0. So you got the derivative of x cube plus c is 3x square, which we got this part. And what is the integration part of this? Integral of again 3x square dx gives, the value gives, that is nothing but 3x cube by 3 plus c. We got it. So these two are derivative and integrals are inverse to each other. So the differential, whatever you got doing the derivative, we are getting the 3x square value. For this, if you integrate it, you are getting back x cube, but coming as an arbitrary constancy, because there are so many antiderivatives for this, not one. That's why we can add an arbitrary constant. Why we are adding arbitrary constant means you can take x cube plus 1, the derivative is 3x square. X cube plus 2, the derivative is 3x square. X cube plus 10, the derivative is 3x square. So whatever the constant you are adding, but final the derivative will be 3x square only. That means for different arbitrary constant, it is giving only one slope, that is nothing but 3x square. So that is the reason of we say that process of differentiation and integration are inverses of each other. That's clear. Now we are going to write the results of the integration. See the first result. Just now I explained you differentiation and integration are inverse to each other. See the concept here. The derivative of x power n plus 1 by n plus 1. We know that x power n plus 1 derivative is n plus 1 times x power n plus 1 minus 1. So clearly n plus 1 the numerator and the denominator is cancelled. And also here plus 1 minus 1 cancel. What you got? X power n. So the derivative of x power n plus 1 by n plus 1 we got as x power n. Therefore, the integration of x power n dx is, for this integration is this. So x power n plus 1 by n plus 1 plus c. Similarly, come to the next one. The derivative of log mod x. Of course, you can write log x also, because logarithm is defined for only positive values of x. So that's why I mentioned here mod of symbol here. So the derivative of log x is 1 by x. Now the differential coefficient of log x you got as 1 by x. Now what is the integration of 1 by x? Is nothing but log mod x plus c. Coming to the third result. The derivative of e power x is e power x. So the integration of e power x is e power x plus c. And fourth result. The derivative of a power x by log a. So log a is constant. So we have to differentiate only the numerator part, a power x. So you know that the derivative of a power x log a, and also 1 by log a is there. Cancel both logarithm. What you got? A power x. So the differential coefficient of a power x by log a I got as a power x. Now integration of a power x is what? A power x by log a plus c. So these four are very useful for us. Coming to trigonometry results, it's very easy to understand. The derivative of sin x is cos x. Integration of cos x dx is sin x plus c. The derivative of cos x is minus sin x. So integration of sin x dx is minus cos x plus c for all x belongs to R. So there is no restriction here. Coming to here the seventh one, the derivative of tan x is secant square x. And the integration of secant square x dx is tan x plus c. But while defining here tan x, you have to take care that x is not equal to 2n plus 1 into pi by 2, where n belongs to z. Of course, I will write here x not equal to 2n plus 1 into pi by 2, where n belongs to z. That means the tan x function is a discontinuous function generally. Tan x derivative is secant square x, but it is differentiable in its domain. What is the domain of the tan x function? Where x not equal to odd multiples of pi by 2. Coming to 8th point, the derivative of minus cot x is minus of cosecant square x dx. So that is nothing but plus will become. Here also the function is defined when x is not equal to n pi, where n belongs to z. So cot x is again, it is a discontinuous function, but it is differentiable in its domain x not equal to n pi. Now what is the integration of cosecant square x dx? Nothing but minus cot x plus c. The same situation coming for 9th bit, d by dx of sec x tan x, but sec x tan x is differentiable where x is not equal to 2n plus 1 into pi by 2. So the integration of secant x tan x is nothing but secant x plus c. Coming to 10th bit, the derivative of minus cosecant x is minus of minus cosecant x cot x, which is nothing but cosecant x cot x. Now integration of cosecant x into cot x dx is minus cosec x plus c, where x not equal to n pi, where n belongs to z. Now what we understood here, students? By observation 5 and 6, sin cos are always continuous functions. It is continuous as well as differentiable. To integrate a function, the function must be differentiable in its domain. That's why we wrote here the integration of cos x is nothing but sin x plus c for all x belongs to R. Every x is valid for this sin and cos. So these two functions are continuous. Coming to 7, 8, 9, 10, all tan, cot, cosec, secant, all are discontinuous functions. So they are made continuous in its domain. For tan, the domain is x not equal to 2n plus 1 into pi by 2. For cot, x not equal to n pi. So basing upon that, we can integrate all these results. So these are the results for handling some problems based upon simple integration. See, the derivative of sin x is cos x. Integration of cos x is sin x plus c for all x belongs to R. The differential quotient of cos x is minus sin x. Integration of sin x dx is minus cos x plus c for all x belongs to R. Here, sin function, cos function are continuous functions. Whenever they are continuous functions, the functions are differentiable. Whenever the function is differentiable, the function is said to be integrable. Coming to tan x, it is discontinuous function. Cot x, secant x, cosecant x. All four are discontinuous functions. We can make them continuous in its domain. So whenever you want to differentiate a tan x, you will get the result is secant square x, but it is differentiable in when x not equal to odd multiples of pi by 2, that is x not equal to 2n plus 1 into pi by 2 for all n belongs to z. Similarly, cot x is differentiable when x not equal to n pi, and sec x is differentiable when x not equal to 2n plus 1 into pi by 2. Same result here comes. So the integration of secant square x dx is tan x plus c. It is integrable when x is not equal to odd multiples of pi by 2. Integration of cosecant square x dx is minus cot x plus c when x is not equal to n pi. In this part only we can integrate it. integration of secant x tan x equal to secant x plus c when x not equal to 2n plus 1 to pi by 2. And final integration of cosecant x cot x dx equal to minus cosecant x plus c when x not equal to n pi. That means these are also integrable in their domain. Coming to the next result about the derivatives of inverse trigonometry functions. You know the derivative of inverse trigonometry function from differential calculus. The derivative of sine inverse x is 1 by root of 1 minus x square. Now this function derivative is this. Now I want the integration of 1 upon root of 1 minus x square dx. Nothing but sine inverse x plus c. Or I can write minus cos inverse x plus c. That means, you know, from the result from inverse trigonometry, sine inverse x plus cos inverse x is always equal to pi by 2. From that, you can write cos inverse x is nothing but pi by 2 minus sine inverse x. And also, this function is integrable where x lies between minus 1 to plus 1. Because you know the domain of 1 by root of 1 minus x square. So the value of x lies between minus 1 to plus 1. Then only this function is defined. The differential is defined. That means in this interval only you can integrate this function sine inverse. So we got that part. Similarly, coming to the tan inverse x, the derivative of tan inverse x, you know from the differential calculus, 1 upon 1 by x 1 plus x square, and the integration is 1 by 1 plus x square dx is tan inverse x. Same concept like inverse trigonometry. You can also write that is minus cot inverse x plus c. And coming to the domain part, here the denominator is 1 plus x square. In the place of x, I can put negative numbers, positive numbers, 0, everything is valid. That's why x belongs to R. Coming to next, the derivative of sec inverse x. Sec inverse x derivative is 1 upon x into root of x square minus 1 if x is more than 1. That means the integration of this part will be 1 by x root of x square minus 1 dx is sec inverse x plus c or minus cosec inverse x plus c from inverse trigonometry result, that is cosecant inverse equal to pi by 2 minus sec inverse x. Suppose x is less than minus 1, the derivative will be minus sec inverse x is same will come here because your x square is positive, but integration comes as minus sec inverse x plus c or cosec inverse x plus c. So students, these are the results you must learn well to handle the problems in integration problems. So up to 13 results you have to masterize to handle the problems. You can easily enjoy the problems based upon these results.